Good afternoon.
Good afternoon, sir.
Yeah, we can start, I think, from where we stopped last time, because last time we had some problem, right? So we will continue with where we stopped last time. I will go back to the same program. Yesterday, we were doing with RCBD, right? Can you all see the screen?
Yes, sir.
Right. Give me a second. Yes. So this is the same program, CRD. Data input. We have treatment, replicate, and yield. Then the cards. If you can go through the data, at last we have the program like ANOVA. Classified variable, treatment, replicate, and so on. Model. Right? Model and run. So we can run and see. So this is our output. Yesterday also we discussed about this output, right? Basically, this output is the ANOVA table. The most important is the probability value, right? Probability value. This p value is very less, 0.0001, even less than that. If you consider our alpha value as 0.05, then definitely alpha value is higher than the p value. Therefore, we reject our null hypothesis. We reject our null hypothesis. So accept alternative hypothesis. The conclusion is there is a significant difference between the in yield what is our example in yield of what? Tomato, huh? So it is your example. What is that example? Yield of tomato, or whatever it is, right? Tomato among treatment. What are the treatment? Your question. What are the treatments? This example given by Sivamadi madam. Can you remember?
5 varieties, sir.
What variety? Variety. Treatment. So that, yes, we can say tomato among the varieties. We could say like this. There's a significant difference in yield of tomato among 5 varieties. Tomato, rice, or whatever it is, right? So this is how you make the conclusion. You can't say here there's a significant difference among treatment. We'll have to tell, because what are the treatment, right? In application, we don't call it as treatment. So we come up with the real name of the treatments, so that we could say like that, right? Okay, right. So talking about that, then any questions? We will go to the next one. Any questions? Right, I will go start with the new sheet. We will go for the next one. Right. Now, I have already entered the data for the second example. You see, this is your second example. What is this? This is from your notes, huh? Do you have the notes of this? This note is from you all. Do you have the note of this?
Yes, sir.
Yes, right. So here, this is our question. You have already done this by manual. Now we are going to do it by using the SAS. So this is the farm. There are 5 farms. Milk yield of cows. How many cows? 4 cows. 1, 2, 3. Sorry. Milk yield of cows, not 4 cows. Totally we have 20 cows. Tell me what is treatment here? Pardon? Diet. Yes. So the diet is the treatment here. So here, conductor investigate the 4 diets. Actually, the results of 4 diets. This is the diet 1. This is diet 2. This is diet 3. And this is diet 4. So 4 diets has been given for the animal. So this is the setup. Now, can you tell me what is block? Because
The block.
yeah, this is RCBD. So that what is block? Farm is the block. Yes, this is we have the block. You see, this is block. So this is block 1, block 2, and block 3. So that we could enter the data as what? We could enter the data, let's say in simple form. How are we going to enter the data? For example, we can enter the data as treatment, block, and milk yield. I'll put it as yield. First treatment, first block, milk yield. First treatment, second block, yield. First treatment, third block, yield. Likewise, for first treatment, fifth block, yield. Then second treatment, first block. Second treatment, second block. So likewise, you can enter into the data. Without wasting your time, you can enter. You have already the data. I have already entered the data in an Excel sheet. I'm going to use that because we are spending a lot of time in, right? So here, can you all see the screen? So this is the diet. This is the farm. This is the yield that I have already entered the data. So, right? Now what I'm going to do is, it is easy way to enter in the Excel sheet. It is easy way to enter in the Excel sheet, isn't it? Because it comes nicely. Otherwise, it's a problem entering the data. We don't miss anything. We can repeat it. Right. Now I'm going to use this data. So I'm going to copy this data. Right. We can copy this data. I'm going to copy this data. Right. Thanush Kumar, problem so I have already entered this data.
Okay, sir.
I'm just going to copy this data. I don't know whether using Zoom, does it work? I'm not sure. Yes. Copy. I have already copied the data. Now I'm going to put it in SAS. Right. Now I'm going to put it in SAS. Right. So the data is there. Nicely come. But we will see. We may come up with some problem. I will explain why it is later. Right. This is our RCBD. So that data, I will say it as RCBD input. What are the input? I will simply put it as diet, farm, yield. So here I don't want to type it as block and so on. Why? Why I don't say it as block and so on? Because we can give it in a name. So diet. The next one is farm and the yield. So here the diet is treatment, farm is block. So cards, the data is there. Right, now you enter, everybody should have this setup. Then Procano. Procano, class, classified variable. What are the classified variable here? Anyone?
Diet and farm.
Diet and farm, good. So we have two classified variables. Now tell me, what is the model? How we can write the model? If you can recall your RCBD model, Yij is equal mu plus alpha I plus beta j plus error term. So what are the things that we want to include in the model? I said we don't need to include the error term. We don't need
Treatment and blocks.
treatment and block. Here we cannot call it as treatment. Yeah, you are fine.
Diet and farm.
Diet and farm. So we know actually the treatment mean it is diet. Farm mean it is block. Right. I'm going to include that. We can include diet and farm. So what is on left side? Look at the name of these three variables. What is on left side? Which equal what?
Y is equal X.
Anyone? What is equal what?
Yield equal yield.
Okay, yield equal
Diet plus.
Oh yeah, we shouldn't say diet plus, diet and farm. Right. So that is why the model is important. If you don't remember the model, then we will be missing out. So what are the source of variance? The diet and the block. Sorry, a diet and the farm. So in originally it is treatment and the block. And run the program. So that's all. You run the program and see the results. Now you can cross-check what is wrong with that. Do you get the results? There's a problem. Can you guess what is the problem is? Because I just want to show the problem is. Can you guess the problem? So I went to the log window and it says something, some story. Error, one or more variables are missing, or frequent, or weight is 0 on every observation. Something wrong with the data. How did we get the data here? What did I do here? How did I enter the data here?
From
Did
the
I?
Excel sheet.
Yes.
From the Excel sheet.
From the Excel sheet. Earliest version of the SAS, if you bring it from the Excel sheet, it will accept. Now it doesn't accept. In the new version, it does not accept. So we'll have to do some treatment. What to do treatment? I will show that treatment also, so that I erase this data. I keep the program as it is. Because program, nothing wrong with the program. Now I will go back. Right? Now we want to convert the Excel data into the form that we can produce. Into the form that we can produce, right? So that I will go back. There's a special type of program available for the conversion. I will show that also. Can you all see this? You know that? Terida?
Yes, sir. Yes.
Right. I'm in the Google right now. So in Google, can you all see the Google?
Yes, sir.
Right. Make a note of it. Huh? Everybody should make a note of it. There's a program called as removing white space. Type removing white space. I hope everybody can see it, right? Can you all see? There's a program called as removing white space.
Yes, sir.
Right. Now there's a web, you see, remove extra white space and tap space. Click that. I'm going slowly. Click that. You have to click that first. I have clicked. Now you will see a window like that. Go back. So you see there are two boxes are there. You can see two boxes. One box is, we'll have to bring our data into this box. Then it produces the same data with compatible to the SAS. Right? Right. Now I'm going to go. Can you all see all of you? Terida?
Yes, sir.
Yeah, this is a special type of program. Two boxes are there. Now I am going to do it one by one. I will go away. I will go to the Excel sheet now. I will show it only for once. Huh? I copy this same data again. Diet, farm, yield, copy. Right? I have copied. Now I will bring it here. Look at very carefully. There are two windows. You paste it in the upper window. You paste it in the upper window. I'm going to paste it here. I have pasted here. Am I fast? Oh, okay.
Okay, sir.
Okay, now I have pasted it. Right? Then, not the first icon, click the second icon, replace both multiple white spaces and tap with a single space. This is the problem, spacing problem. Right? Click that. Then there's a icon to be pressed called as replace white spaces. Replace white spaces. Rania, is it okay?
Yes, sir.
Okay. Remove or replace white spaces. So normally, before clicking that, in the second box, it is empty here. You see, we have entered the data here. We have actually entered the data here. Here, this is empty. Right? Now, I'm going to click this box. Once you click, you will get now data. You have new set of data. I mean, the same data has been placed there. Actually, this same data is there. But now it has been recorrected for the space. Now it is compatible with the SAS. So that I'm now going to copy this. So for the copying, you go a little further. You see, copy the clipboard. I'm going to copy this. Is it okay with everyone?
Yes, sir.
Right. I have copied. Now it is copied. Now I will stop displaying this, I need to go to the SAS now, right? I need to go to the SAS. I will go to the SAS. What I can paste what I have copied. Now I am going to paste it what I have copied, right? Now you see these are not necessary. This is not necessary actually, right? Only the data I need. I have removed all the titles and so on. I have already entered these titles now, right? So let me be careful. Here you have the semicolon. Now it is not the same data. I have converted because you can do this only if you are copying from some other program, any program. Notepad, you can bring it from the notepad also. It is text form, in text form, right? Even you can bring it from the Word, no problem. But you'll have to convert it. All right. Now the same program, no different in the program. Now I am pressing. You see, now you get the output. Now you get the output. You can try this. Everybody should try. Even in the exam, if we give this Excel file, you should be able to convert this, right? Anybody having problem with the conversion? කාටාද ප්‍රශ්නයක් තියෙනවද convert කරගන්න? හරියට ප්‍රශ්න එරකෝ convert කරගන්න convert செய்யறதுக்கு? It says removing white space. If you type it, it will give. All right, because there are so many programs removing white space. Only a couple of programs compatible for SAS. So you'll have to be familiar with that. Right? Now, as usual, we can explain the rest of the information as the output. So here, this is the first box. It's indicating what are the levels of diet, what are the levels of farm, how many diets, how many farms are there, what are the categorical of diet and the farm. So 1, 2, 3, 4 is the diet, 1, 2, 3, 4, 5 is the farm categories. Total number of observation is this. Right? Now, not like CRD, in RCBD, you see here the model statement, model information. Actually, this model information is given below, right? Right. So this model information, you see, this model is actually expanded here. In the model, what are the components do we have entered? Yield and, sorry, what are the components that we have entered? Diet and the farm. So you see diet and the farm, which included in the model, right? Diet and the farm. All right. So here in this example, if you add all these information, suppose let's say degrees of freedom. If you have 3 plus 4 degrees of freedom, so definitely we have 4 diets. 4 minus 1 is 3. We have 5 farms. 5 minus 1 is 4. So you see here, the diet degrees of freedom is 3. Farm degrees of freedom is 4. What is the addition of this? 7. That is you are getting here in the model, because model is split into diet and farm in this case. In the CRD, we don't have problem because only one component explaining the model, which is treatment. So that's why we had same value in the model and the treatment. Here, not like that. So everything, for example, at the sums of square values, at these two values, it is same as this sums of square values. Right? Not mean square, only the sums of square. Okay? So sums of square and degrees of freedom, when you add for the diet and the farm, it is same as the model one. Right. So here, it's including the significance of both. Model significance, it is depend on the weightage of the significance of both diet and the farm. Right? Give me a second. Somebody is knocking the door. Give me. All right. So here, when you add these sums of squares, as I said, either sums of square or the degrees of freedom, it is same as the model sums of square and the model degrees of freedom. So that is one thing. So as I said, since the model is including both components, diet and the farm, if you look at the model significance, this is significance because why? Our p-value is, this is our p-value. So definitely if the alpha value is 0.05, right? If the alpha is 0.05, definitely this p-value is much less. So that model is significant. But here we cannot take the decision why model is significant. We want to go individually whether treatment is significant. That is our main aim. Sometimes here there may be, model may be significant. Maybe treatment may not be significant. Why? Because model is here diet and the farm. So whenever the model is significant, maybe the farm is significant. Diet may be not significant. Therefore, by looking at this, whether the model is significant, we cannot come to a conclusion saying that diet is significant. So we'll have to go specifically to the diet and see whether diet is significant, because diet is our treatment. In this example, diet is our treatment. So that look at it. So diet is no problem. It is also significant. No problem. So it is less than the alpha value, so that we could say that what is the conclusion now after taking the decision? What is the conclusion? Anyone? How we can make the conclusion? This is my null hypothesis. My null says alpha I is equal 0. Alternative, at least one treatment effect, or rather than saying one treatment effect, one diet is one diet effect, I will say effect is different from rest. At least one diet effect is different from the rest. So that is the alternative. So we accept the alternative based on the results, right? What is my conclusion? What is my conclusion? Anyone? Anyone? What is my conclusion?
There is a effect of diet on the yield, milk yield.
Yeah,
Significant
there's a significant effect of diet
on milk yield.
on milk yield. That is one say. That is one type of saying that we can declare. Then other type of declare, how we can say in another way, at least one diet has different yield. What yield? Milk yield. At least one diet shows different milk yield compared to the rest of the diet. At least one diet shows difference in milk yield compared to the rest of the diet. When you say at least one diet shows the milk yield, that means it shows the difference in milk yield. So that means it can be higher value or lower value. That we don't. At least one diet different from the rest of the diet on milk yield. Right? So we can write it in that way also. So in the exam, we'll have to write just producing this is not enough. Anyone can produce, no? If you give it to your brother or your sister at home, this is how you run the program. She also can produce it, no problem. Grade 10 people or grade 11 people who are doing programming, they can also do it. So people are doing bit and IT and this and that. They can run the program, no problem. If you know the set of commands, anybody can run. But they cannot interpret as you do interpretation. That is the difference. Is that okay, Dhanesh Kumar?
Yes, sir.
That is the thing. So if you produce the program and the output will not work. What we expect is one step more. Okay. So this is what we are expecting from you undergraduates, right? Right. Now you see, there's a small problem. In this case, I will get with the CRD, then explain in detail.
Sir, excuse me.
Yeah.
Sir, Nate showing us on the missing data.
That is what I'm going to do it now. Yes.
Okay.
Right. So here, I will go for coding and I will save it first, then. I'll go for CRD. Yesterday's example, not today's one, yesterday's example. Let's say now I have a missing data here. Suddenly, this is a tomato yield. No? In Kilnochi, you have done this research. You couldn't obtain the yield here. Why? Because you don't have any fences. No. Suddenly, cow came, some cow or cattle or whatever came, eaten your plot. It has eaten your plot because it is tomato. So you don't have yield. You don't have yield. What to do? This much of data. This much of data. You cannot throw the data. All the other data is there. Now this data is missing. In SAS, you can analyze missing data also. What treatment, what replicate is missing?
Second treatment, third replicate.
Second treatment, third replicate is missing. In SAS, you simply add a dot. for the missing data. Make a note of it, right? So we add a dot, all right? We add a dot for SAS. In SAS, for a missing data, we indicate by adding a dot. Is it clear to everyone? Right. Just by adding a dot, I'm going to run the program. You see, it will not run the program correctly. I will come to that. Right? Yeah, it's there may be a problem. You see here, what is the total number of observation earlier?
25.
25. So we had 25 basically data. You could see here the number of observation read is 25 because including that dot. Actually, the number of observation used for analysis is 24. So he has used only 24 for analysis. He has omitted one, kicked off one, right? Now he has done the analysis. No problem in degrees of freedom of model or the treatment because still 5 treatment. Treatment number doesn't change. This is changing. Why? The degrees of freedom for total is changing. Why? Because only 24 minus 1. That is 23. So based on that, here you have error degrees of freedom. Now 19. Earlier it is 20 error degrees of freedom. Now it is 19. Then if degrees of freedom changes, what will happen to the error? Error also will change because, sorry, error mean square will change because mean square is totally depends, and sum square also slightly changes, not very big because one data is missing. So the total sum square will be slightly different. A treatment sum square also slightly different because one data is missing. Everything is slightly different, but still it is significant. So we can analyze that data also, right? For the missing data. So don't worry about if one plot is damaged. Don't cry like a child is, right? So you can still do the analysis. That doesn't mean you'll have to spoil all the what do you call plots. I mean, naturally it may happen. Let's say you are doing some field experiment. There was a heavy rain during the rainy season. What will happen? Maybe 1 or 2 plots may be totally damaged by the flood. So what to do? Nothing can be reversed. So that definitely you'll have to go with the remaining data, right? So that is how we do it. Maybe in laboratory, for example, we are doing some Petri dish studies, right? What will happen? Normally in that Petri dish studies, there may be fungal infection. There may be fungal infection. So if there is a fungal infection, what to do? We have a problem, right? Then we may have to throw this dish because we cannot keep the dish further. Maybe germination test or whatever the test. So these are some practically we may come across this kind of problem. So how we can continue with that, right? In the older version, actually, if you run the program with the missing data with the same name of the program, it will not work. But here in the new version, it works, right? There is an advantage of that. Right. Any question? So this is just a indication of the distribution of each treatment. Let's say you have different treatment 1, treatment 2, 3, 4, and 5. How they are distributed. So from this, you can identify, this is on y-axis yield. From this, you can identify which treatment is giving high yield.
Yes.
Huh?
Fifth one.
Pardon? Which treatment is giving high yield?
Fifth treat.
Fifth treatment, yes, good. So fifth treatment is the one which is giving high yield. Similarly, which treatment giving the very low yield?
Fourth treatment.
This is the fourth treatment giving the very low yield. So you can visually see this. Now I'm going to talk about mean separation, which you need to study the theory. I'm not going to explain theory now because your madam will be explained. I will explain little on mean separation. Then we will go back to mean separation. So mean separation is done when the treatment is significant from the ANOVA table. When the treatment is significant from the ANOVA table, then we can go for mean separation. If the treatment is not significant, then we don't need to go for mean separation. Right? If the treatment is not significant, then no point of going for mean separation. Right? I will, in a nutshell, I will explain some mean separation called as least significant difference. It's called as LSD, not the Latin square design. Huh? This is least significant difference. This is one method. Second method is called as Duncan method. We will learn all these another theory class. The third one, Dunnett method. The fourth one, Turkey method. So these are method, all these methods are based on single comparison. What do you mean by single comparison? I have treatment, 4 treatment, let's say T1, T2, T3, T4. This milk yield, we said milk yield earlier example, milk yield. So T1 versus T2, T1 versus T3, T1 versus T4, then T2 versus T3. So likewise, how many comparison possible? How many comparison, individual comparison that possible? Anyone? How many comparison possible in this example? 4 treatment. At a time, we take only 2. How many possible pairs are there for comparison? How many? 6 comparisons. 6 possible comparisons. If you have 10 treatment, how many? If you have 6 treatment, how many possible comparisons? 6 treatment. How many possible comparisons? Let's say T1, T2, T3, T4, T5, and T6.
50.
Illa. Yes. You said 15. Yes, 15. Yeah, 15, 1, 5 comparison. Yes. So there's a formula T into T minus 1 divided by 2. So this is equal 6 into 6 minus 1 divided by 2, which is 15. Right? So this is the possible comparison. So the method that I have mentioned here, all these methods are comparing one at a time. Right? Then other type of comparison is called as group comparison. I don't know whether you will learn it, but I'm just telling for the fulfillment of group comparing. T1 versus T2 plus T3 divided by 2. So this is a group comparison, isn't it? Because here it is coming as a group. Right? It's coming as a group. Let's say my T1 is T2, T3, T4. T1 is, I will say, T1 is 50%, 50% urea. T2 mean 75% urea. Just an example. Huh? T3, 60% of organic. T4, 80% of organic. Now I say I'm going to test T1 plus T2 divided by 2 versus T3 plus T4 divided by 2. Can you tell me how this comparison could be? How this comparison could be expressed? How these comparisons could be expressed? In real example, T1, T2, T3, T4. These are the 4 treatments. Now I'm comparing average of T1 and T2 versus average of T3 and T4. How we can express this? Anyone? How we can express this? Yeah. How we can express? Yes. How we can express? Any suggestions? Any clarifications? How we can explain this too? Anyone? Sorry.
In urea, highest and lowest values.
Huh? In urea, highest and value.
50% is lower than 75. I don't know if that is correct.
Pardon? Arosha?
No, so in urea, the two treatments are one is slower than another one.
Yeah.
So we can compare those.
No, I'm just, let's say my objective is to compare the average of T1 plus T2, average of T1 and T2 versus average of T3 and T4. Nowadays, it is a critical topic.
Then urea and organic.
Yeah. What is urea?
Inorganic fertilizer.
Now my objective is I want to compare inorganic versus organic. In my experiment, I want to compare inorganic versus organic. So what about this T1, average of T1 and T2? It is inorganic or organic?
Inorganic.
Inorganic. Source of nutrient, that is, I mean, what type of nutrient, we will forget it. Because we can give nitrogen from urea, we can give nitrogen from organic matter, no problem. Now, our aim in this case, the comparison, group comparison, this is what I said, group comparison, right? You will learn from the theory. So, group comparison, here, my objective is organic versus inorganic, right? Meantime, I can compare this one also. In that case, what is my objective? In this case, what is my objective?
Levels of urea.
How? Whether it is 50% urea is better or 75% urea is better. In that case, a different objective. So in this case, a different objective. So we can test, even in a group of experiment, we can test based on the objective. So this is what we call as mean separation. It takes about 4 hours for me to teach the whole mean separation procedure. So you will learn from Madam the mean separation techniques, right? Okay, I don't want to talk about theory much. So now I am going to look at the application. When you talk about the application here, there are occasions where we use these different tests. For example, these two tests, 1 and 4, that means LSD and the Turkey test are more or less same. So when you do LSD or Turkey is more or less same. So that is first information. Second information, LSD is done for a small number of treatments. When you have small number of treatment, when you have 3 treatment, 4 treatment, even you can do it for 5 treatments, number of treatments, small number of treatments. Duncan is done for large number of treatment. When you have large number of treatment, let's say you have 8 treatments, then Duncan is better. You will learn all these theory later, right? In Duncan, we say all possible comparison. In Duncan, all possible comparison. We can do all possible comparison. There are problems when you start doing all possible comparison. That you will learn in the theory class. There are bit of errors coming. Error will be accumulated. The Donut, it is interesting. I will use the other page. Donut is done to compare with control. What do you mean by control? Next year, when you do not next year, maybe when you are starting your 4-2, then you will come up with control. What do you mean by control?
There is no any treatment.
Oh, not necessarily. Not necessarily. Yes. Anyone? Now let's say
the condition.
Go ahead. Go ahead.
What condition we are going to test for the that control test? We won't consider. We won't give that condition.
Right.
Without
How do you know fertilizer recommendation? Do you know anyone fertilizer recommendation for some crop? Example. Anyone? I can tell you more fertilizer recommendation for either crop. Kaatari dannawada fertilizer recommendation monari crop eකට කිව්වනම් උදාහරණයක් කියන්න. So I will give you what is control. Somebody said control. Who said control? Arosha. Is that Arosha?
Yes, sir.
No treatment, right?
Yes.
Right. Now, sometimes we cannot say no treatment. I have an experiment, 0 nitrogen, 15% nitrogen, 0% nitrogen, 15% nitrogen, 30% nitrogen. If you measure the yield, can we say 0% nitrogen yield is better than 15% nitrogen or 30% nitrogen? Can we say, because I'm putting 0 nitrogen for one plant, another plant 15% nitrogen, another plant 30% nitrogen. Can I conclude? Can I get the yield from 0% plant? I mean 0% nitrogen applied plant as the higher yield. Is it logic? Arosha තමයි උත්තර දෙන්න ඕන මට. Arosha, where is that?
No, yes, sir.
කියන්නකෝ Arosha කියන්නකෝ. නෑ මගේ මං ආපු ප්‍රශ්න තියෙනවද දැන් අපි 0% nitrogen දානවා එක පැලයකට. තව එකට 15% තව එකට 30යි. අපිට කොයි අවස්ථාවක් කියන්න පුළුවන්ද? අපිට yield බලන්න නැතුව කියන්න පුළුවන්ද 0% දාපු එක අනිවාර්යෙන්ම yield එක වැඩි වෙයි කියලා අනිත් තුන්ට වඩා?
Better can't.
Huh?
Better can't.
We can't say. Why? Because already in experiment we prove that applying more nitrogen, I mean up to a certain level, applying nitrogen will increase the fertilizer. That we have already known source. We don't need to do an experiment with 0 fertilizer versus 15% nitrogen. So this is a unnecessary research, because by applying some amount of nutrient or nitrogen will definitely increase the yield. තේරුණාද? දැන් අපි හැම වෙලෙම බිඳුවත් එක්ක කම්පෙයාර් කරන්න ඕනේ නැහැ. எங்களுக்கு பவுண்ட் சைவரோட சைவர் 0 வேல்யூவோட கம்பேர் பண்ணணும்னு இல்ல. கம்பேர் பண்ற அவஸ்தா இருக்குது, கம்பேர் பண்ற அவத்தையால் இருக்குது. So you cannot just compare as we want. So control doesn't mean always no treatment, right? So we'll have to be careful. But I don't know. I ask fertilizer recommendation. Anyone knows? Agronomy people. Nelum, you know? How they agronomy people? Who are the agronomy people? No agronomy people. Soil, right? I will just. What is the urea application for paddy? Anyone per hectare? I also don't know. I'm just asking. Let's say 100 kilograms urea, right? Then 40 kilograms of MOP. Then merit of potash is 40 kilogram. What is the other source of fertilizer that you are using?
Yes.
Huh?
TSP.
Superphosphate, right? Triple superphosphate. That is, let's say 50 kilogram. As an example, I don't know really the actual value in 1 hectare. So people say this is the best, I mean, this is the recommended by the department. Agriculture, DOA. Department of Agriculture recommended that. There may be some department people, huh? I forgot. Who are the department people? Very difficult to catch those people. They should know. So this is the recommendation. Now, people are saying we want to reduce the fertilizer, this and that, and this and that. Now, I'm going to do a small research. Let's say 90 kilogram of urea, right? In one package, 90, 40 merit of potash, and then triple phosphate, 50. So this is treatment 1. Another treatment, I have 95 urea, right? Then 40 kilogram of MOP, and 50 kilogram of TSP. This is T3 as an example. Now, I want to compare. This is control. I want to compare always C versus T1. This is T2. Huh? C versus T1, C versus T2. These are the two comparison I want. This is C mean we are practicing at present. This is what I am thinking, whether by formulating the T1, whether we can have better yield than the present one or the recommended one, control one. So this is control. This is called as control. So here we compare versus control. So this is called as recommended one is called as control. We compare with control, T1 and T2. Is there any point comparing T1 versus T2? No point of comparing T1 versus T2. Because already we proved that control is better. So now we want to compare control versus the rest. So here we can use the technique called as the Donut. Donut is always Donut is always used to compare with control. Donut is there to compare with control. Is it clear? So there are different techniques are there. Right. Now I'm going to discuss some of it. Right. We will go back to our SAS. Here we found that in these results, we found that treatment is significant. Now you see, treatment is significant. I will go with the original data, right? I'll go to the code. I don't save it. Huh? So this is my original data. Right now, look at it. If you can run and you will get the same results. This is without missing data. All the data is there. So that is there. Tanis Kumar, can you all see the screen?
Yes, sir. Yes, sir. We can.
Right. So now that is the output. So based on the output, we come to a conclusion there is a treatment effect. Now I'm going back, and this is how we can include the program for mean separation. Write down very carefully. It means. It says mean, not mean, means. Right? This is a statement, means. Under the ANOVA only it goes. If you type it just means, will not work. Means. Which one we want to separate the means? For which one we want to estimate the means? For replicate or for treatment here in this case? Which one we want to compare? Among the replicate, among the treatment?
Treatments.
Treatment. So we say treat. Stroke. Option. We can give any option. I said some methods are there, different methods. First, I will go for LSD method and run the program. Means treatment LSD. Have you all written down? This is the additional information that we are writing. Right? Okay, I ran the program. First, a few tables as usual we have. We go for the last table. Have a look on last table. I will come with a glass of water, then we will discuss. Right. I hope everybody has gone through the output. Now, can somebody comment on this? Actually, I cannot express the first. Can you all hear me?
Yes, sir.
Yeah. The first table, everybody knows this is my alpha. This is error degrees of freedom from the ANOVA table. This is the error mean square. What is error mean square? Because it is also needed for the calculation. I will come to that. Error mean square, I will go up and show. You see, this is mean square of error. What is the value mean square of error? This is the mean square of error, 0.034. That is my mean square of error. So that we can go down, right? So you got all these information. Mean square error is there. That is from the ANOVA table, right? Degrees of freedom, that is also from the ANOVA table. This is alpha. These three are these two. This is the critical T value, T table value. Can you remember? With the degrees of freedom. Total, you will learn this, how to look at the T table. T degrees of freedom. Sorry, the degrees of freedom. This is the T value, table value. Then this is called as LSD value. You will learn in the how to calculate. There's a calculation process to calculate the LSD value or least significant value. What is happening is, look at this LSD value. What is the LSD value? Tell me. 0.2433, right? 0. Is that correct?
Yes, sir.
Right.
2, 4,
Right.
3.
What is happening is, I will go a little further. Right. This is the most important picture. This is the LSD value. Normally, I'm comparing, let's say, yield of first treatment, mean yield of first treatment versus mean yield of second treatment. If the absolute value is greater than the LSD value, then we say there's a difference between first treatment and second treatment. Because here, this is treatment 2, average yield of treatment 2. This is the average yield of treatment 1. If you take the difference, if the difference is higher than the LSD value, then that means there's a difference between those two treatments. Suppose, let's say, this is my mean of the which treatment? This is treatment. Which treatment? Fifth treatment. Estimate mean, it is the mean value. So fifth treatment mean value is 2.82. Then what is next? It is in the ascending order. Sorry, descending order. The next one is the third treatment. The lowest treatment is fourth. Value is fourth. Earlier in the graph we have identified now. Highest value for fifth treatment, lowest yield for fourth treatment. Right. Now these are the mean values. So fifth treatment is there. Next one is third treatment. What is the mean value? 2.50. What is the difference between these two? Mean if I compare treatment 5 versus treatment 3, what is the difference? What is the absolute difference? Absolute difference. absolute value. කීයද වෙනස? දෙකේ අතර. ඉතින් රැන්ඩම් කොමඩේල එவ்வளவு විத்தியாசம்? The mean value.
0.32.
0.32. This 0.32, is it higher than the LST or lower than the LST?
Higher than it.
Higher than the LST. So, is there a difference between these two treatment? Fifth one and the third one?
Yes.
Yes. There's a difference between treatment 5 and 3. So, if there, in addition to that, which treatment is better?
50.
Fifth treatment, because it is having higher yield, right? So that fifth treatment is better. So that is how we can compare in all this. I have shown you in theory class, you will learn all these things. Anyhow, right? That is one way to look at it. The other way, you see the colors. This treatment mean is having one color. This treatment mean is having another color. This treatment mean is having another color. This one is having another color, and this one is. All are having different colors. That means all are different. So when you write the report, treatment, you write the mean here. I will simply write not all decimal, 2.82. This is 2.50. The next one 2.18. Next one 1.76. 0.94. Right? Treatment 3. 2.14. I have rewritten there. Now, when you write scientifically, you have to be a little careful, make a note of it. So that means here we write A, B, C, D, E. We say means with, write down, means with same letter are not significantly different at alpha equal 0.05. In this case, alpha is 0.05. In the table, the alpha is 0.05. Here also it's given. So write down this very carefully. Means with the same letters are not significantly different. You go home, study, and come back. Right? So I have put A, B, C, D. So that means A, here I have A. Mean with the same letters are not significantly different. If means with different letter are, if you write it other way, means with the different letters are significantly different at alpha 0.7. So that means, do we have difference between these two?
Yes.
Yes, because treatment 5 is A, treatment 3 is B. So there's a difference. This is how we can give the letters. Like you are getting your grades for each subject. So likewise, we are giving kind of grading. We will go with the other examples also. Right? Right. I will go to the other one also, then we can do some exercise. I will go for RCBD. I will take the RCBD that we have ran. So we said when you do the RCBD, according to that, the treat diet, there's a significant difference among the diet. Right? So So what is next step? Then we'll have to go for mean separation. The next step is definitely we should go for mean separation. So I will go for mean separation. Right. So what do we write? So here 4 diets are there. So I can use the LSD, no problem. Means here, can I write treatment, stroke, LSD? Am I right or wrong?
Wrong.
What to be written?
Treatment and block points.
Means කොයි අතරද means බලන්න යන්නේ means වෙනස බලන්න යන්නේ එතකඩේල means විත්‍යාසම් පාක කරන yeah
Diet.
Diet. So don't forget that diet. Now you run. Now you see this table we know already. Now interesting, again the same story. All are having different colors, right? All are having different colors. I'm going to play around a little. Just a second. Treatment, diet 4 and 3 having high value. I'm going to change some value. 4 and let me see 4 and 3. 3 and 4. I'm going to change my data. Having 3. I'm going to change this 3 a little bit. I'm going to play around. Don't worry about that. I'm going to increase these values. 4.3. For example, this value is 4.3. What was the, just a second, what was the mean? 4.3, 5.56. I'm just playing. So worry. 5 and 4.8. I'm running again. Don't worry. I have changed only these 2 data just to show you a different output. Now the story is different compared to earlier. Do you observe the here? What was the earlier system? Now what is the different now? You see the treatment is significant. Look at the table. Treatment is significant. You see? That means the diet is significant, no problem. But I have played with some different data. Now tell me what is the story? Anyone?
Fourth and third diet are not significant.
They are not significant. 4th and 3rd. Earlier, 3rd and 4th are significant. So this is, yeah, earlier different color. Now it is same color. So I say diet is the mean value or the estimate. So I say 4, 3, 2, 1 diet 5.56. The other one is 5.42. 4.42, 3.8. Here you see the LSD value. What about the LSD value here? Which value is higher, LSD value or the estimate difference is higher? Estimate difference between 4th treatment and 3rd treatment. What is the difference here? Anyone? 0.14. Here 0.53 is the LSD value. So LSD value is higher than the difference, so that no difference between this fourth treatment and the third treatment. So here, likewise, you can check all. Here, how we can letter? Anyone? How we can letter? How can put the wheel, write down the letters?
We should give both the same letter.
Which one?
4th and 3. 4 and
Excellent. Good. What about treatment or diet 3? Sorry, diet 2.
that is different from 4 and 3.
Excellent. So this is how we mark it. So once you mark it like this, we don't produce this in the book. We don't produce this in the thesis. We produce this in the thesis because we need the mean value we want. So everybody knows that if you have A in these two treatment, that means there's no difference between those two treatment or those two diets. So feeding with diet 4 and 3 give more or less same results, right? But they are giving higher milk yield than the treatment 2 and 1 or diet 2 and 1. So that is one information that you can say. The lowest yield obtained from feeding with diet 1. So this is how we can interpret. Any questions? I'm not going to talk much about the mean separation further. Yes. I will show you one more thing. Again, I'm going back to not this data. I'm going with CRD, for example. I'm going to change the mean separation techniques. Right? Have you all written down? Some mistake, huh? Have you all taken down? Can you remember when we can use Dana?
Compare with control.
Right. Now here we don't specify computer what is control. But you see, computer will automatically take only one group as control. How it's take? Let's look at. I ran the program. Now look at this table. I'm not going to explain this again. Look at this table. What has happened? Can you guess what is which one the computer has assumed as control?
First.
Yeah, first treatment it considered as control. So in your real experiment, if you are doing SAS, if you need to compare with control, always you will have to enter the data as first of the control. Control should be entered first as treatment 1. நீங்கள் அப்போ என்டர் பண்ணிக்க சாஸ்ல கண்ட்ரோலோட கம்பேர் பண்ணணும்னு ஒரு ப்ரோக்ராம் வேணும்டா உங்களுக்கு. அப்போ நீங்கள் கண்ட்ரோலை முதல் டேட்டாவா என்டர் பண்ணணும், முதல் ட்ரீட்மெண்டா என்டர் பண்ணணும், பிறகு என்டர் பண்ணக்கூடாது. ஓகே, ඒ කියන්නේ අපිට කන්ට්‍රෝල් එක හැම වෙලෙම කම්පෙයාර් කරගන්න ඕන නම් හැම වෙලෙම SAS ප්‍රෝග්‍රෑම් ලියනකොට data ටික එන්ටර් කරගන්න ඕනේ පළවෙනි ට්‍රීට්මන්ට් හැටියට. ඊට පස්සේ එන්ටර් කරා නම් එයා කම්පියුටර් හැම වෙලෙම ගන්නේ පළවෙනි ට්‍රීට්මන්ට් තමයි කන්ට්‍රෝල් හැටියට එයා හැම වෙලෙම කන්සිඩර් කරන්නේ. ඒ නිසා ඒ විදිහටම කරගන්න. Is it clear? Now here we compare each cases separately. You see, 5 versus 1, 3 versus 1, 2 versus 1, 4 versus 1. 5 versus 1 is a positive value, mean difference. If it is positive value, what is higher? 5 or 1? Treatment. Five is 5. Yes. So 3 versus 1. It is again positive. So 3 is higher than 1. 2 versus 1. It is again positive. 4 versus 1. It is negative. So which one is higher in mean yield?
First treatment.
1 is higher than 4. You see? And also, the other thing that you can observe is in each comparison to see whether these are significant. In each cases, it is significant, highly significant, very highly significant. It's same results as our LSD. Can you remember? We put LSD, same results. Ondukondu vyatyasapadadu ave high. Ekin eka venasak tiyenawa so that it is highly significant. Any questions? I'm just giving a flavor of mean separation because you didn't study the theory, so it doesn't matter. Keep this in mind for your practice. Whatever I teach you, you'll have to go and practice. Computer is you need to practice. Otherwise, it's you will forget it. Right. Any questions? Shall we stop with this? Tomorrow morning also we will do SAS. But the link is in the other thing, but we will use the SAS. Huh? It's the link is in the design, but we will do the SAS. Let me check the time. Yeah. Are you all want to skip? Saraswati Pusai Purnama illa Thavaya?
Phone, sir.
Etra manikku? Adu 6 mani thane appa. Sorry, yeah. Yes. Any questions? Any questions? We will have to cover a little bit. What do you call? Tomorrow we can cover this Latin square, then nested, then split plot. Right, these 3. Tomorrow, anyhow, morning and evening we can cover it, hopefully. Any questions? Any questions? Peony?
No,
Rosha? Any questions?
Sir,
Yeah, go ahead.
Sir, unexplained variability ஆலே error வருமோ அல்லட்ட unexplained variability தான் error வரும்?
இல்ல இப்ப என்னென்றால் இப்ப வேரியபிலிட்டியை பொறுத்தவரை நார்மலா ஒரு வேரியபிலிட்டி ஒன்று இருக்கும். டோட்டல் வேரியபிலிட்டி அப்படியோ அது மாறாது. ஒரு டேட்டா எடுத்தோம்னா ஒரு ஈல் எடுத்தோம்னா அந்த டோட்டல் வேரியபிலிட்டி மாறாது. ஓகே. When I take the total variability, it will for a given set of experiment, the total variability remain as it is, same for an experiment. Let's say yield, I have collected the yield data from maize, so the total yield variation in the maize will be considered as total variability. Now thing is, it's up to us how this variability can be partitioned into different components, right? Our main aim is to, as much as possible, we should reduce the component of unexplained variability. For example, let's say if we have total variability as such, total variability as such, then we say this is due to treatment effect. Right? So one part is explained by the treatment. Suppose if we had the block, then we say this is block effect. So another part has been removed from the total variability. So likewise, whatever the possible component that we can use to explain that among the total variability, we should do it. After completing all the explanation due to different components, still there will be some component remain, right? Okay, that is called as unexplained variability or the error, or that is called as residual. So it's called as different names because we try to implement all possible explanation, still some remainings are there which we cannot explain. So that is called as error or residual or unexplained. Okay.
Okay, sir.
Right.
Thank you, sir.
Any other questions? Madhusha, understood?
Yes, sir.
Okay. Yoshani,
Yes, sir.
is it okay? You got it?
Yes, sir.
Okay. Indujalani. Understood? Okay, right. Any questions? You can ask any questions, even from the theory or practical, no problem. Even though we had a tight schedule, I think you might have benefited, hopefully. Yes. Tarshini,
Yes, sir.
சொல்லுங்க விளங்கிச்சதோ?
Yes, sir.
Subangi,
Yes, sir.
right. Okay. So எல்லாரும் yes ன்றீங்க அப்படின்னா எல்லாரும் 100க்கு 100 எடுக்கும். හැම එකනම yes කියනවා. නමුත් 100 ගන්න විභාගෙ. ඇයි ඒ? එතන no sir. Now yes sir. What is the problem? Right. Everybody, you'll have to enter your data tomorrow in SAS and bring it. What are the data? For example, factorial. We'll have to do factorial also. Right? Factorial. What else? We'll spend some time on factorial. The others I will introduce. Split plot. The same example that we have done. Factorial, what is the exam that we have done? Example that we have done, factorial. On what? Vidusha, what is the example that we had in factorial? Vidusha, no. Who else? What is the example in factorial? Yes?
Programming and memory.
Programming and memory. Enter those data and come for the class. What is the other example? Yeah? Split plot. Nested, can you remember area and the site example? I have already uploaded in the net also, area and the site. That example, you enter the data and come. Then it is easy for us you to run the program. At least write down the data, enter the data. Everybody knows how to enter the data. Then we can write the programs later on. Then what is last one? Split plot. We did split plot. I couldn't remember exactly. Yes, we did irrigation and what do you call, variety or something, right? So type all the data, get ready in SAS, bring it. Right. I think we will wind up and see you tomorrow morning at 8.
Thank you, sir.
Okay, bye.